Hello, we are going to discuss this subject of hydrology in this series. So, hydrology. What is actually hydrology? Hydrology is defined as the study of water. Let's take up a new screen here. Hydrology can be defined as the study of water, and there are main three things which are done or executed in the hydrology subject. It is first the occurrence, second is the circulation, and third can be said as distribution. Therefore, occurrence, circulation, and distribution of water on our earth is known as hydrology. Therefore, to sum up, one could say that hydrology is the study of water that deals with the occurrence, circulation, and distribution of water on earth. Now, earth doesn't confine only to the surface, it means the entire biosphere, which means includes the atmosphere, hydrosphere. Now, in order to learn more aspects about hydrology, we need to understand few terms. For example, hydrological cycle. What does hydrological cycle mean? Now, since we are talking about the occurrence and circulation of water and the distribution thereafter, how does the water come into existence? Now, there are various terms how water arises. For example, let's take a simple view of a coastal area, or for that matter of fact, let's take a very simplistic view in which we will discuss the coastal area, the mountainous area, and various areas. Let's say this is a water body. For example, let's take it's an ocean or a sea, and here we go, these are the landforms and elevated areas. Now, you have already in your earlier classes you are well aware about the land breeze and sea breeze. Therefore, let's talk that, for example, clouds arise. Once the water evaporates from here, the clouds move towards the landward areas and water precipitates. Therefore, precipitation could be defined as one form through which water comes. Alright, so precipitation is one form in which water comes. Now, after precipitation is further divided into various forms. For example, hail, rain, similarly sleet, and so on. Now, this precipitation is a part of hydrological cycle. Similarly, after precipitation, some water runs off or filters down. Therefore, this is filtration, or could also be said as infiltration. This part is runoff. Now, there would be, in all this, there would be some trees too. Therefore, these trees also absorb some water. There is another phenomenon, that is transpiration. These all phenomena we'll discuss further in detail, but just to give an overview, it could be said that hydrological cycle, let me first erase everything here. Hydrological cycle is a cycle in which water moves from one phase to another. Therefore, phase 1 to the another phase and another phase. But the thing to remember here is it's a cycle. Therefore, it would be a continuous process. Although, since water is in a large amount on the earth, and similarly for long ages water has not gone extinct, therefore we could say it is a continuous cycle. But this could be wrong if we are talking about long term perspective, but nevertheless that is not the scope of the subject. So for us it is a cycle in which water moves from one phase to another. But you might have a question, that does it have same residence time in each phase? Now, while speaking that sentence, I said residence time. Now, residence time is a term that means residence time. It is exactly how it sounds. The time for which the water resides in a phase is known as residence time. Now, moving further, or just to put it mathematically, residence time can also be written as the volume of water in a phase. Let's say water in a phase divided by the discharge in that phase. For example, let's talk about the runoff. If a 1 meter cube of water is running off from this particular section, then this discharge which is going from through this particular section on average is 1 meter cube per second, then in this section the residence time for water would be, you have guessed it right, 1 second. Therefore, residence time could be defined as the time taken by the water particle in crossing one particular phase of the hydrological cycle, or like I've already said, the residence time is the amount of time or the time for which the water remains in a particular phase. Now, there's an interesting phenomena that sometimes is asked in an interview, that is precipitation more on the land or on the ocean? So one must remember that precipitation is more in the land. Now, this was the fact, but how is it true? Or even if it is true, that has to be seen. For that, let us see both the phenomena. From where does the water come in the oceans? Runoff, right? Is there somewhere else also from where water comes in the ocean? Well, one could say precipitation. Okay. And how water leaves the ocean? If this is ocean and this is land, it leaves through evaporation. For this is E, let's say this is R runoff, and this is precipitation P. Now let's talk about land. Now, how water leaves land into the ocean, for let us suppose it leaves through runoff, right? Absolutely right. But along with the runoff, water also evaporates, right? Water evaporates from land, therefore it's a loss for land. Loss. But from where do land get water? That is similar to oceans, that is precipitation. Therefore, if we talk about the water budget equation, which we will be discussing in the further slides, precipitation can be defined as, not precipitation, but the water budget equation for land would be P is equal to E plus R. The outgoing water should be equal to the ingoing water, and similarly P plus R is equal to E. Therefore, this can be seen if, let's assume that the amount of water completely goes into the ocean and nowhere else, and there is no amount of losses that take place, then precipitation on the land would be more than the precipitation in the ocean side. Therefore, on comparison, we can say on ocean precipitation is lesser than the evaporation, and on land precipitation is higher. Now, this was just a storage equation, water budget equation. Now, there are various applications of hydrological cycle. Hydrological cycle can tell us how much, or if not how much, how the water is getting transferred over the earth. For example, I've already told you that precipitation, transpiration, depression, storage, these are all different forms or phases that occur in a general hydrological cycle. Alright, now since we were talking about the terms, there is one term which you might have often heard about, is catchment area. Now, catchment area is the area from which water drains into a river. So therefore, the area which is draining into a river or a stream is called catchment area of that stream at a particular location. For example, I'm talking about a location A. Therefore, the amount of water from A that drains into the river, for example B, will be known as the catchment area for B at A. Now, this might have been confusing for some of you. Let me break it down. If there is a river B and there is a particular space A, the water that drains out from A into the river B is the water that is contributing to the flow in the river B. But catchment area would be defined as the water that is draining, or the area from where the water is draining. Alright, therefore we would say that A is the catchment area for B at A only, because there could be another area also B which would be draining into the river B, but in that case B would be the catchment area for B, but not at A, at B. Therefore, catchment area is defined as the area from which the water is draining into the river or catchment for that particular location only. Alright, now having talked about our catchment area, let's talk about ridges too. That what ridge means. Now, usually, or in general sense, a ridge is a elevated piece of land. For example, let's say this is a piece of land. This would be defined as ridge. Similarly, ridge could be this is also a ridge. Now, one could say that see, if there is water in this area, excuse me, if there is water in this area, this ridge line will obstruct the water from getting into the other area, and so for this area. Therefore, ridge line can also be defined as a line which demarcates one catchment area from its neighboring catchment area. And ridge line is also famously known as water divide. Now, what is the force that drives all the entire hydrological cycle? The force that drives the hydrological cycle can be defined as, or said as, the solar force, and second would be Coriolis force. Solar force derives its power from sun, or energy from sun, and Coriolis is because of the rotation of earth over its axis, which is responsible for the Coriolis force. Now, we had earlier talked about the water budget equation. The water budget equation is simply the storage, which is equivalent to the inflow and the outflow. Now, let's say, let's take a hypothetical example. For example, there's a water tank, and at t equal to 0, the amount of water it has is say 1 unit. At t equal to 5, the amount of let's say that input is going in at 5 units per second, 5 units per second, and there's no outflow, or let's assume there's an outflow of 1 unit per second. And in that case, at t equal to 5, we'll observe that the amount of inflow was 25, since 5 into 5, and outflow would be 5. Therefore, storage would be 20 because of this. S is equal to I minus O. Therefore, we could properly write this as delta S is equal to I minus O, which is inflow of water and outflow of water, is equal to the change in storage. Alright, so this is the water budget equation. Now, water budget equation could be properly written as in other forms too. For example, this was the general overview, but if there are various inputs, for example, I've already said that precipitation is one input, runoff is one input. Now, it depends. For example, let's talk about land. For land, precipitation is input, whereas runoff is not an input, evaporation is not an input. Alright, so these would act as losses. Losses occurring in the catchment area. This course is strictly for discussion, and will be separately solving numericals in some other session, so kindly refer through to those videos for numerical solving. Now, one more fact, that the amount of water, which is fresh water, which is approximately available, or was at one time available, was 1386 mega kilometer cube on Earth. Now, this is the amount of fresh water present on Earth that is free, almost easily available for us in form of glaciers, I would say. Alright, I beg your pardon. not in form of glaciers. This is the total amount of water present on Earth, and out of this only 96.5% is unfortunately saline. Well, this is not an only figure, therefore only 1% is available on land which is saline. Therefore we do not have much of water with us. So it is a request that we need to secure our resources, especially the water resources. That is, if we assume that we have 1400 megakilometer cube of water, in that approximately 97.5% is saline, in which 1% is in water, is on land, and the rest is on ocean. Therefore we are left out by only 22.5%. Now 2.5% of 1400 is approximately 35 megakilometer cube, over which also only 1/3 is present in the form of, is easily available for us, and rest 2/3 is in the form of glaciers. Therefore we can easily estimate that only about 12 or say 11 megakilometer cube of water is easily available, but there are more hurdles. Most of the water is not properly utilized. We have a very high runoff coefficient, and also we are responsible for the pollution on the in the water bodies. Let's discuss about another term, that is average rainfall. But in order to calculate average, we have to know what the annual rainfall is. Average rainfall is, for example, I have 2 readings or 3 readings of rainfall. We take average, but how do we take average? What kind of average we need to find out? These will be discussed in the later slides. But before that, let's discuss annual rainfall. Now, annual rainfall is calculated annually. For example, the amount of water that is collected, so to say, the amount of water collected in a particular year is known as the annual rainfall. But the average taken up for a long period, for example, let's say 30 to 35 years, is known as average annual rainfall. But the amount of water, if calculated for 24 hours, would be daily rainfall. Alright, therefore the terms average rainfall is a generic term, but annual rainfall is the amount of rainfall that occurs during the year. And on the other hand, average annual rainfall would be the rainfall of that particular area for a long period, or a long average of about 30 to 35 years. Now there is another term that is quite popularly used, long period average. Now this average is taken for a quite larger period, that is 50 years, and it is not that every year this changes. These are also taken up as a ranges, and as and when required, these are updated either decadally or at a certain suitable appropriate time period. Now let's discuss one parameter. It is known as index of wetness. Now, what is index of wetness? It is defined as rainfall in a year, or in a particular year, divided by average annual rainfall. And if we have to calculate it in terms of percentage, then we have to multiply it by 100. Alright, now depending upon what is the index of wetness, we can calculate rainfall deficiency. For example, since we are calculating percent rainfall deficiency, or let me change the color here, rainfall deficiency will be 100 minus index of wetness. Now depending upon what the rainfall deficiency is, we could define how the year was. What do I mean by how the year was? Is whether we had good rainfall, whether we had a bad year, or whether it was in general a normal year, that there was nothing extraordinary. So let me prepare a table here. See, if the rainfall deficiency lies between 30 to 45%, or if it lies between 45 to 60%, or if the rainfall deficiency is greater than 60%, depending upon these ranges, alright, one can define how much serious or what is the intensity of deficiency. If it is 30 to 45%, it is large deficiency. Now if this is large, then this should be serious, because 30 to 45% deficiency is a huge number. But then in that case, 45 to 60% would be a very, very serious number. But then what if the deficiency is greater than 60%? Then in that case, it is a disastrous situation. Therefore, that particular situation would be a disastrous one. Alright, therefore, the point to be remembered here is, if the rainfall deficiency is 30 to 45%, we have a large deficiency. Serious deficiency is 45 to 60%, and a disastrous deficiency in case the rainfall deficiency goes beyond 60%. Now one more thing one has to remember, or one must know, is, as we were talking about how the year was or year would be. Now year could be normal, bad, or good. Now depending upon the index of wetness, if our index of wetness is greater than 100%, well, since we are talking about normal, if our index of wetness is equal to 100%, it is a normal year. If it is less than 100%, it is a bad year. And in case if it is greater than 100%, it is a good year. Moving ahead, this was all related with the water. Now one more point people might have in mind, that there are some places, let's talk about India for example. There are places in India where there are floods, or there are areas where floods occur due to the precipitation or various other reasons. For example, there is a place in Meghalaya, Mawsynram, where the precipitation go as high as 11,000 mm, and so on. And there are a few areas, some would say deserted areas, in some particular location where the rainfall is too less, and even drought-like situations occur. So This is one thing that has to be kept in mind, that drought and flood are region specific. They do not occur entirely for a particular country or a large area. Now let's talk about drought. It is a climatic situation, of course, in which we have dearth of water. That is, the availability of moisture is not sufficient. Now, drought can be also defined as meteorological, hydrological, and agricultural. Now, what does a meteorological drought mean? Meteorological drought is because of the precipitation loss or deficiency in precipitation. Whereas, if one has to talk about the hydrological drought, it is due to the deficiency in discharge in the average stream flow. Whereas agricultural drought is characterized by the deficiency of water available for plants consumption. Therefore, agricultural is related to plants. This is related to discharge in the stream, and this is related to precipitation. Now, having said that, let's further categorize the droughts. The meteorological drought is further divided depending on the deficiency in precipitation. If it is greater than 25%, it is just a drought. If it is 25 to 50%, it is a moderate drought. Whereas if it is greater than 50%, then it is a severe drought. Now, one more point to remember here is that if in a particular year the area which is affected by drought is greater than 20%, then that year is called as drought year. Whereas if drought occurs in an area with probability between 0.2 to 0.4, then that area is known as drought prone area. Whereas if that probability is greater than 0.4, then that area would be known as chronically drought prone area. Unfortunately, India has about 34 to 35% of its area which is drought prone. Now, talking about the hydrological drought, we have already discussed that it is the phenomena in which the average stream flow decreases in the streams, and similarly the storage areas, natural or artificial, for example lakes and reservoirs, the amount of water decreases. And the third type of drought was agricultural drought, in which the water available for plants consumption reduces. Now, there is one particular index which we should know, that is known as Aridity Index. Now, Aridity Index is defined as PET minus AET divided by PET. And if we have to measure it in terms of percentage into 100. Now, what is PET AET? PET is the potential evapotranspiration, whereas AET is the actual amount of evapotranspiration that occurs. Now, potential evapotranspiration is the water which would be consumed by plants if sufficient water would have been available in the soil. But if the sufficient water is not available, in that case we define what actually happens, and that is AET. Now, depending on what the aridity index is, an area can be further divided as mild arid region, or moderate arid region, or severe arid region. this range is similar to what we have discussed about droughts in the meteorological drought, 25 to 50 and greater than 50%. Well folks, let's conclude this till now, and we'll see you in the next video, hopefully. Thank you.